Hi everybody, in this section we're going to talk about the sum and difference identities for sine and tangent. In the last section we got the sum and difference identities for cosine, and those lead to the sum and difference identities for tangent. So we'll pick both of those up in this section, and we'll see how each of those identities came about, and then we'll work a few problems using each one. So let's get started. Let's start by finding the sum and difference identities for sine. So we'll start this process by looking at the cofunction identities for sine theta. So sine of theta equals cosine of 90 degrees minus theta. We had that in the last section. Now, if we substitute a minus b in here in place of theta, then we'll get sine of a minus b equals cosine of 90 minus parentheses a minus b. See how a minus b just took the place of theta? We can do that because we did it in both spots. Now, this negative here in front of this two-term expression needs to be distributed. So let's distribute that minus sign, and that will give us 90 minus a minus minus b, which is plus b. So that's just distribution. Now let's kind of regroup. You know, the associative property says we can group any way we want to, so let's group together the 90 minus a. Okay. Now the reason I wanted to do that is because now I have kind of a setup here that's cosine of one thing plus another. So my 90 minus a is my one thing. So let's use the identity for cosine of a plus b, but in this case a is actually 90 minus a. So it's going to say cosine of 90 minus a times cosine of b minus sine of 90 minus a times sine of b. So again, that was us using the cosine of a plus b identity, where what's in parentheses here is a and this is b. Alright, now let's use the cofunction identities again. Cosine of 90 minus a, we know from our cofunction identities, is equal to sine of a. And then we've got cosine b. And sine of 90 minus a is equal to cosine of a, and then times sine of b. So we now have a new expression, a new identity. Sine of a minus b is equal to sine a cosine b minus cosine a sine b. You do not have to memorize this. If I had to memorize this, I'd just have sines and cosines just running out of my ears. So these are on your identity sheet. You just have to be able to find the one that you want. So sine of a minus b is this one. Now let's take a look at the sine of a plus b. To do that, we will start with the identity that we just got, which is the sine of a minus b, and we'll do the same thing we did on the cosine section. We will replace b with negative b. Alright, now, minus negative b is actually plus. And here, let's use our negative angle identities. Cosine of negative b is equal to cosine of positive b. And here, sine of negative b is equal to negative sine of positive b. So I've just pulled that negative right out. Negative, negative is going to make plus. And we'll end up with sine of a cosine of b plus sine of b cosine of a. Alright, so there is another identity for us. That's our sine of a plus b. And here are both of those identities together so you can see how similar they are. If you've got sine of a plus b, you get a plus between the terms. If you got sine of a minus b, you get a minus between the terms. They're both built the same though. Sine A, cosine B, cosine A, sine B. Alright, now let's look at the sum and difference identities for tangent. So I'm going to start to find the tangent of A minus B by using our quotient identities. So that is sine of A minus B over cosine of A minus B. Okay, we have an identity for sine of A minus B. So I'm just copying from the identity sheet, sine A cosine B minus cosine A sine B. And then for the bottom, we have an identity for cosine of A minus B. That's going to be cosine A cosine B plus sine A sine B. Now, I need to get this simplified somehow, but you cannot cancel anything here because I don't have anything that's a factor of the whole top or a factor of the whole bottom. So in order to create something that can be simplified, we're going to do something that you might not ever think to do. And that is, we're going to multiply top and bottom by 1 over cosine A cosine B. I know it seems weird at first, but you're going to see it's going to do something nice for us. So I'm going to multiply each term in the top and each term in the bottom by 1 over cosine A cosine B. It's okay to do it as long as we do it to top and bottom. Alright, there it is for the first one, and there it is for the second one, and now the bottom. Okay, now we can reduce. In the first fraction, the cosine B's will cancel. In the second fraction, the cosine A's will cancel. In the first bottom fraction, the cosine A's and the cosine B's will cancel. And in the second bottom fraction, actually nothing cancels. Okay, so let's see what we got. The first fraction in the top reduces to tangent of A because it's sine over cosine. The second fraction in the top reduces to tangent of B. The first fraction in the bottom reduces to 1. And the second fraction in the bottom reduces to tangent A, tangent B. Alright, now there is the identity for tangent of A minus B. Okay, now let's find the tangent of A plus B. We'll start off with tangent of A minus B, and we will do what we've done on the sine and the cosine. We'll replace B with negative B. Alright, now using our negative angle identities, tangent of negative B is equal to negative tangent of positive B. And in the bottom, same thing. See, in the top, go back to the top. Negative tangent of positive B made minus negative tangent B. So minus negative made plus. And here the same thing's going to happen. This will become tangent of, or it will become negative tangent of positive B. So that negative is going to eventually end up out here. Alright, so the minus that goes out here, change that plus to a minus. And here is the identity for tangent of A plus B. And we had to use the negative angle identities to get that. Okay, here they both are. Then you can see that just like cosine and sine identities for A plus B and A minus B, these are very similar. If it's tangent of A plus B, you get a plus in the top and a minus in the bottom. If it's tangent of A minus B, you get a minus in the top and a plus in the bottom. Okay, now we get to use these to actually work a few problems. And our first problem is find the exact value of sine of 75 degrees. Okay, now remember, this whole section we're talking about A plus B or A minus B. So the whole thing hinges on being able to use two of our known angles to come up with two angles that add up to 75 degrees, or subtract to make 75 degrees. So it has to be angles that we know the values of. So I'm thinking 30 and 45 because we've used those before. And then the sine of 75 is the sine of 30 degrees plus 45 degrees. Now, plugging into our sine of A plus B identity, we have sine of A cosine of B plus cosine of A sine of B. And you can look at your identity sheet, and you should, and make sure that you see why we chose the A plus B identity, and make sure that you see that we plugged into it correctly. After you've plugged into it, you can go back and substitute your known values. Sine of 30 degrees is 1/2. Cosine of 45 degrees is square root of 2 over 2. Cosine of 30 degrees is square root of 3 over 2. Sine of 45 degrees is square root of 2 over 2. Alright, now multiply these two fractions together. And multiply these two fractions together. And now combine these into one fraction. Now, if you remember, just a little tip here, if you remember back in the last section, we found the cosine of 15 degrees, and it had the same answer as sine of 75 degrees. That's because 15 and 75 are cofunctions. So of course cosine of 15 equals sine of 75. So let's go on and look at the next example. Okay, we've got here, find the exact value of tangent 7 pi over 12. Well, I think the first thing I would do is convert my 7 pi over 12 into degrees. So 7 pi over 12 is equal to 105 degrees. And the reason I wanted to do that is so I could more easily think of two angles that could add together and make 105. And I think we could use 60 and 45. Remember, our only choices are 30, 45, and 60, so it's not like we have a whole bunch that we have to sort through. So tangent of 105 degrees is going to be equal to tangent of 60 plus 45. And now we're going to use our tangent of A plus B identity. And that's going to say tangent of A plus tangent of B over 1 minus tangent A tangent B. Alright, substitute your known values in here. Tangent of 60 is square root of 3. Tangent of 45 is 1. In the denominator, 1 minus square root of 3 times 1. And that's what we're left with as an answer, square root of 3 plus 1 over 1 minus square root of 3. But of course, we should not leave that radical in the denominator. We need to rationalize that denominator. If you remember from algebra, to rationalize a denominator that has two terms, you have to multiply the top and bottom by the conjugate of this. So remember, conjugate is when you use the same two terms but a different sign in between them. All right, watch what happens when we multiply these two conjugates together. All right, we're starting with the top. In the top, we're using the FOIL method. So, actually, let's go ahead and put parentheses around those so it looks like we should use the FOIL method. The fraction bar would kind of do that for us, but you might not realize it. Alright, first times first would be square root of 3. Outer times outer would be 3. Inner times inner would be 1. And last times last would be square root of 3. Going to the denominator, first times first is 1. Outer would be square root of 3, and inner would be negative square root of 3, but those would add up to 0. And then last times last would be minus 3. Alright, now combining like terms, I have, in the top I have square root of 3 plus square root of 3, and I have 3 plus 1. So 3 plus 1 is 4. Square root of 3 plus square root of 3 is 2 square root of 3, and in the denominator, 1 minus 3 is negative 2. Since each of these can be divided by 2, we should do that. 2 divided by 2. Oh, we're going to split the fractions up. Alright, so here I've split this up into two fractions where the denominators are both negative 2. 4 divided by negative 2 is negative 2, and 2 divided by negative 2 is negative 1. So negative 1 times the square root of 3 is negative square root of 3. Now, I would encourage you to punch tangent of 105 into your calculator and make sure that that decimal value is the same as this decimal value. You know, just for a double check, but it should be fine, and in fact it is on this example. Alright, for our next example, let's find the exact value of sine 40 degrees cosine 160 degrees minus cosine 40 degrees sine 160 degrees. So you want to look at your identity sheet and see if you can find one that looks like sine times cosine minus cosine times sine. And what you will come up with is that sine of A minus B equals sine A cosine B minus sine B cosine A. So the 40 is taking the place of the A, and the 160 is taking the place of the B. That means we can put 40 and 160 here. Alright, now 40 minus 160 is negative 120. We can figure out the sine of negative 120 pretty easily because that's one of our special angles. Negative 120, you have to go clockwise around the circle, and if you go 120 degrees clockwise, you'll have a reference angle of 60, and your sine value will be negative because you're in the third quadrant. So the sine of 60 is square root of 3 over 2, but it's negative in the third quadrant. So that turns out to be negative square root of 3 over 2. And you'll see that if you do punch this into your calculator, it'll give you the right numbers, but it will not look like this. So it will not look like an exact value, and that's why we can't just go to the calculator. Okay, here's kind of a similar one. This is from exercise 22 on page 221. It says find the exact value of, and it's got this formula here. This looks like one of our tangent identities. In fact, it is the tangent of A minus B. Alright, so it looks like the A is 80 and the B is negative 55. That means I'm going to plug in here 80 minus negative 55, which is 80 plus 55, which is 135. Alright, so the tangent of 135 is what we have to come up with, and if you remember, 135 has a reference angle of 45, so its tangent, the tangent of 135 is 1, but it's negative because it's in the second quadrant. So tangent of 135 equals negative 1. Okay, here's another one, kind of similar. Sine of one angle times the cosine of another plus cosine of the first angle times sine of the second. Alright, we need to see which identity this matches. And it does seem to match our sine of A plus B identity, where A would be pi over 5 and B would be 3 pi over 10. Now, to add these together, instead of going to degrees, let's just bite the bullet and do the addition here. 1/5 pi plus 3/10 pi is going to be the same as 2/10 pi plus 3/10 pi. That's just using common denominators, and that will give us 5/10 pi, which reduces to 1/2 pi, and we know 1/2 pi is equal to 90 degrees. And the sine of pi over 2, or 1/2 pi, the sine of pi over 2 is equal to 1, because we know that the sine of 90 degrees is equal to 1. Okay, now this one says write each function as an expression involving functions of theta. This is just going to be a matter of plugging these two things into our sine of A plus B identity. So the sine of A plus B says sine A cosine B plus cosine A sine B. Now sine of 30 degrees we know is 1/2. Cosine of 30 degrees we know is square root of 3 over 2. And now there's nothing we can really do much to simplify here, except we can combine those two into one fraction because they both have a denominator of 2. So that's all there is to that one. let's do tangent of 45 degrees minus theta. Now we can use our tangent of A minus B identity. So that's going to be tangent A minus tangent B over 1 plus tangent A tangent B. We know that the tangent of 45 degrees is 1. So 1 times the tangent of theta is just tangent of theta. And there you go, 1 minus tangent of theta over 1 plus tangent of theta. Okay, for part C, we've got sine of 180 degrees minus theta. So we know that 180 can be the A and theta can be the B. So it'll be sine A cosine B minus cosine A sine B. Now the sine of negative 1, or not negative, sorry, but the sine of 180 is negative 1, or 0 rather, oops. The sine of 180 is 0, and the cosine of 180 is negative 1. And so this turns out to be 0 cosine theta minus negative 1 sine theta, which equals positive sine theta. Okay, this one says, suppose that A and B are angles in standard position. Find each of the following. Sine of A equals 4/5, and A is in quadrant 2. Cosine B equals negative 5 over 13, and B is in quadrant 3. So first we want to find sine of A plus B. We'll just use our identity. Now, they gave us the sine of A, and they gave us the cosine of B. These other two values here we'll have to find. So down here I'm working on angle A. I know that angle A is in quadrant 2. I know that the vertical side is 4 and the hypotenuse side is 5. So the horizontal side must be 3. Alright, now we're going to be able to find the cosine of A. For angle B, we know angle B is in quadrant 3. We know that horizontal and hypotenuse are 5 and 13. So you can use the Pythagorean theorem to say the square root of 13 squared minus 5 squared, and that would be 144 square root, which would be 12. So the missing side is 12. Alright, that's going to allow us to find sine of B. So let's just fill in here what we know. Sine of A is equal to 4/5. Cosine B is equal to negative 5 over 13. Remember, it would be negative because cosine in the third quadrant is negative. Alright, then cosine of A would be negative 3 over 5. And sine of B would be negative 12 over 13. Alright, now 4 times negative 5 is negative 20, and the denominator is 65. Negative 3 times negative 12 is positive 36, and the denominator is 65. So to add these two fractions, we do negative 20 plus 36, and that is 16 over 65. Okay, tangent of A plus B, we will use our tangent of A plus B denominator, or identity rather. So tangent of A, we can get from here, tangent is going to be negative 4 over 3. And tangent of B is going to be positive 12 over 5. And in the denominator, we do 1 minus tangent of A times tangent of B. Alright, now let's kind of be careful with our little arithmetic here. Negative times negative is going to be positive. And 4 times 12 is 48, and 3 times 5 is 15. So that fraction becomes plus 48 over 15. Notice that I did not take the trouble to add these together, because what I'm going to do now is just simplify this complex fraction. We are going to multiply the top and the bottom by 15, because 15 is the common denominator for all of these little denominators. So here we go, multiplying each term by 15. And okay, I had a negative sign in here that I had to take out because it did not need to be negative. Okay, so let's simplify each of these. 15 over 3 is 5, and negative 4 times that 5 is going to make negative 20. Here, well, I don't have it multiplied out yet. Here, 15 over 5 is 3, so we're going to have 12 times 3. Okay, and I had to correct that same sign error there, so 15 over 5 is positive 3, and it's times 12. Now in the denominator, 1 times 15 is 15, and here 15 over 15 cancels out, and we're left with plus 48. Okay, now negative 4 times 5 is negative 20, 12 times 3 is 36, and the denominator is 63. Negative 20 plus 36 is going to be positive 16 over 63. Okay, now the next thing they ask us is to find the quadrant of a plus b, and you might be thinking there is no possible way, but it's really pretty simple. If sine is positive and tangent is positive, there's only one place that a plus b can go. Okay, sine of a plus b came out positive, tangent of a plus b came out positive. That means the only possible quadrant is quadrant 1. And we'll pick up one verify problem here. We want to verify that this equation is an identity. Look at the left side of this equation. You might not know any other identities that will work, but if you can use a sum or difference identity, practically all the work is done for you. So this is telling you you have to use the sine of a plus b and the cosine of a plus b, and all you have to do is plug it in and let it go. So the sine of a plus b is going to be sine of a cosine of b plus cosine of a sine of b, and then cosine of a plus b is going to be cosine a cosine b minus sine a sine b. And all of this is going to have to simplify to what we see on the right side. And so we're going to do it using the known values. Sine of pi over 6 is sine of 30 degrees, which is 1/2, times cosine theta. Cosine of pi over 6 is square root of 3 over 2, because remember pi over 6 is 30 degrees, times sine of theta, plus cosine of pi over 3, which is 60 degrees. Cosine of 60 degrees is 1/2, times cosine of theta, minus sine of 60 degrees, times sine of theta. Alright, now, look at your positive square root of 3 over 2 sine theta and negative square root of 3 over 2 sine theta. Those add up to 0. And you're left with 1/2 cosine theta plus 1/2 cosine theta. 1/2 plus 1/2 is 1 cosine theta, which is what we wanted.